Can I share my screen now or not?
Yes, you can.
I can see the meeting is live screen. Can I continue?
Yeah, you can continue. Just proceed like you've seen the tutors do up until now. Just
Okay.
continue. Free. Yeah.
All right. So we will be good, good afternoon, everyone. My name is Ridwan Ibiduni. So we'll be talking about advanced prompt engineering and Langchain, which is our focus for this session of the program. So we're going to give some background information of the concepts we will be dealing with today. And then after the background information, we'll try and see the implementation in code. So the first thing that we want to talk about is a form of prompt technique. Firstly, we'll be talking about the zero-shot prompting. So we have different prompt technique that are used with large language model. So the first one is zero-shot prompting, and this technique is is used in such a way that when you want to request something from NLM, you give it an instruction which we call prompt. And this type of zero-shot prompting does not require an extra layer of explanation or example. That's why we call it zero shot. It means that you are just giving it a prompt like this particular LLM, for instance, ChatGPT, what is a noun? For instance, it's just a question you are asking, or you give it a question, I mean, a prompt that will just be like an analogy. The sky is blue. Maybe you want it to generate something along that line, but you will not give it explanation, you will not give it um, analogy or example. So this is called zero shot prompting. So the second type of prompting that AI engineer use for large language model is called few shots prompting, which is another layer compared to zero shots. This involves giving the LLM, the large language model, some explanatory, form of prompting, or having a layer of example to the prompt you have given to it. Now, what this means is that I will not just give the large language model the prompt. For instance, I can say uh, Ridwan is a naming word. For instance, Ridwan is a naming word. So also Kehinde is a naming word. So I'm giving more than one, example to explain the concept of noun. Instead of saying a noun is a naming word, then I'm giving an example that Ridwan is a naming word, Ayo is a naming word. So these two examples that I've given to it will give the LLM more context or more explanation on what you are talking about. So in few short prompting, rather than giving it a prompt, ordinarily, you are going to reimburse or make the prompt more robust by giving it more example or more explanation. That is called few shot. It can be one example, we call it one shot. It can be two example, and so on and so forth. That is few shot prompting. Then the third type of prompting that we use is chain of thought prompting. This means that this particular type of prompting it's used when you want to when you want to solve a logical, problem. If you have a mathematical question that you want to ask, chain of thought prompting enables the model to exhibit complex reasoning capability by guiding it through sequence of related prompts. So in that case, it means that when you have a series of steps to be followed to solve a particular problem, mathematical problem, for instance, or logical problem, for instance, then you can use a chain of thought prompting to prompt your model. We're going to see this implementation in the code shortly. So in case you have any question, of course, you can always interject and then state your question. So the first type of prompting is zero shot chain of thought prompting, which is also like a layer of or a kind of chain of thought prompting. In this prompting technique, it involves adding the phrase "let's think step by step" to the original prompt. You have given a prompt that looks like chain of thought. Then at the end of this prompt, you are adding the phrase "let's think step by step." And this is going to give a breakdown of the logical step the model has taken to solve a particular problem. Then also we will be getting into the long chain, the definition, its definition, and then how it's built and the rest of them. But before getting into that, let's see these prompting techniques in action. I'm going to switch over to my Colab. So I'm using OpenAI, of course. I have my key here. Then this is zero shot prompting. Can So in this zero shot prompting, this is just its implementation. I imported the OpenAI, I imported client class, and I passed in my key into it. Then this particular approach of message was the one we first used in our first class, where we have role defined, which gives the type of definition you have. This one represents system, which is, it means the computer system. So the content is the content that I want the system to identify. For example, in this case, I want this message to classify the text into the neutral, negative, or positive. By implication, that means I'm doing what we call sentiment analysis. I want the system to know, I'm giving it context. This first statement gives the message, the system context. What did I want you to do? I want you to do sentiment analysis, classifying the message I give you after this into three classes, basically. Then we have the role, another role defined for the user. This is you giving a prompt, user status now, and the content is, I think the vacation is okay. So this is my real prompt. This is my real prompt here. I think the vacation is okay. And this, based on the context you have given it above, then of course you are creating a completion, and of course you are using this type of model 3.5. Then when I run it, I have the response to be neutral, because of course I think the vacation is okay is a neutral, statement. It is neither positive nor negative. This is zero shot because I only give it a prompt to work with. I have not given it example or analogy and so on. So the second one we talked about was few shot prompting, and that one is more like adding layer to the zero shot prompting. I have it defined as above. We have system giving it the context of what I want it to do. I said the task is to correctly use words in a sentence. That is the context that I want. Then I'm defining another role for the user. Then the content of that is to give it sentence. This Watu is a small village, Fiore animal native to Tanzania. An example of a sentence that uses the word Watu is, we were traveling in Africa and we saw these very cute watpos. To do a fadubu means to jump up and very fast. An example of a sentence that uses the word fadubu is, so in this case now, I am giving a more, robust sentence that I want it to identify the next word that will fit in this sentence. You can see from here, I said an example of a sentence that uses the word fathable, and I've explained the word fathable here. I said to do a fathable means to jump up and very fast. So with this explanation here, then it's going to give me the right word or the right text that will follow this sentence. An example of a sentence that uses the word fathable is, then I have my output here. The children were so excited to watch the kangaroo fadubu over the fence at the zoo. This is a very contextual and meaningful sentence because it make use of that variable, which is the context of jumping up and down, for another sentence entirely, because I have given it an example to work with. And that is few short prompting. So any question so far? So moving on, we have what we call the chain of thought prompting. And that's also followed the same paradigm, but we said it is used when you have logical statement that you want to implement. Of course, I have the system role defined for the context, and I have the user role, which is my prompt. So I have my prompt in sequence of, series of in inverted comma. Then of course I give this also, like I said, this one also combine different examples, which is talking about few short, but the chain of thought prompting here is introduced because we want to deal with logical question. We have the odd number is in this group add up to even number. Then we give it an example. Then we also explain adding all the number. This is just a context, and we give it an example also. So the same thing we do it for the second, example and second statement. We did that for more than 3 examples. So that means we give it more than one examples, which we can also classify this as an example of few short prompting. But because we are using it in the case of logical statement or logical problem, it is not just few short, it is chain of thought prompting. So at the end of the day, when I give it the last statement, the odd number in this group add up to even, then of course it gave me the output that completing the chain of thought, the odd number in this group add up to this, and so on and so forth. Let me know if you would like to continue with more prompts. Okay. That's just more explanation or more request from his own end. Then finally, zero shot chain of thought works the same way when we are using it for chain of thought, but the only difference is that we are not going to give it as many examples as we done for the chain of thought prompting. So for instance, I went to the market and bought 10 oranges and 5 apples. I gave 5 oranges to the neighbor and 2 apples to the repairman. I then went and bought 5 oranges and ate it, and so on and so forth. Now, this one is a statement, of course. Then I'm now asking the question, how many oranges and apple did I have left? Let's think about it step by step. So we said zero shots, we had the phrase, let's think step by step to it. But this question is a problem statement, it's a mathematics problem statement that the model has to think about. But I'm not giving it an example of this type of case, that's why we call it zero shots. So in that case, then you see the output to be step one, initialize purchase, and it told me everything it did step by step in order for me to understand what is going on behind the scene. So this is a demonstration of each of the prompt statement. Then I would like to move on to the um, next aspect of the class. Any questions so far? All right. So moving on, we are to explain what we call Langchain, and it's an open source framework that helps AI engineer develop application that is powered by large language models such as ChatGPT. That means we can embed large language model like ChatGPT in some application to help build that kind of application. So he said it offers a standardized interface for connecting language model to various data source and agent, and it enables interaction within the environment. So Langchain is like framework. Programmers or developer, when they want to build software, for instance, an app developer, for instance, if he or she wants to build software on native application, he has to use a framework. Example of such framework can be Android Studio, and the web developer have their own framework. So framework encapsulates those complex code. Instead of writing a lot of code, then you can use framework to fast track your development and make your work easier. And that's what Langchain is going to do for AI, application developer. So instead of writing a lot of code to bring this together, then we use Langchain to fast track its development. So this is just a representation of the components that Langchain use to build, to connect application together and build an AI applications. So Langchain enables the construction of NLP application by linking components from diverse modules, facilitating the creation of custom applications such as sentiment analysis, chatbots, and the rest of them. So if you want to create any kind of this application, you have to be familiarized. You have to familiarize yourself with the component of Langchain, and we have all of them represented, or most of them represented in this diagram. We have agent, we have prompt, and the rest of them. Then I think I will just give a brief explanation about some of the components that are used to bring about Langchain. The first one is model IO, which stands for the input output interfaces for language model. It provides a standardized way to interact with different language model, allowing for seamless integration and interoperability within the Langchain. What that means is that the way of passing in or passing out, items within that interface, Langchain interface, is done with this model IO component of the Langchain. And it's very important for us to know how to use this particular component. Another component that is important is prompt template. We see this prompt template. An example can be seen in a large language model like ChatGPT. It gives predefined structure or prompts for composing, prompts to interact with the LLM. So the prompt template helps standardize the way you should ask the LLM, questions, so that it's going to be more structured, and that will help it give, coherent and contextual, responses. So another component that is important for long chain is memory. Whenever we are dealing with large language model, one of the most important thing that we need is remembering, because this type of model, they don't have memory, and that's why we have the advent of RNN and LSTM, for instance, recurrent neural network and long short-term memory model. So memory is also a major component in LangChain. It helps the framework remembers, so that it's going to keep up with the context of the question or the test you're asking it. Memory is also very important. Another one is agent. Agent is a component that is responsible for interacting with the model. Agent is the one that will be sent by the framework to interact with other components and the outside world generally. So when the lang chain want to interact with database, for instance, it is the agent that is going to do that. When it want to fetch data, when it want to, do other thing or interact with other component, I think it's agent that is going to, bridge this gap between the lang chain and then other component or the outside world. Then chain their sequence of call to component, and then these components, this chain helps to brings the interaction, which is kind of core, that will change the other components together. And the chain are used to maintain context and coherence in the generated text by providing a structured approach interacting with the language model. Then I think finally we have our vector stores, which we can see in this diagram up here. The vector stores is data structure that is used to store and manage vector representation of text data. One major, component of LLM or unstructured data, for instance, especially text. Let me be specific on text. Is that text data cannot be represented on computer memory. They can only be represented by converting them to number. There is what we call cosine similarity in NLP. Cosine similarity helps bring together words that have is a mathematics notation. It helps bring together words that have a very close, context. For instance, man and king, they have the same context. They can be used in a very close context. So cosine similarity, that particular mathematics intuition, put them in the same close range in vector space. And that's what we call cosine similarity. Women and queen also, they can also be put in the same, the same position or close proximity in vector space. And this concept brings about what we call embedding or word embedding. So this vector space is used to store, it's used to enable efficient, data storage and retrieving them using what we call vector embeddings. So because when you have tests, they can't be stored as tests, they have to be stored as embedding that I've just explained now, which are numerical representation of tests that capture the semantic information. These vector embedding are often used as input in machine learning model for various natural language processing tasks. So I think these are the most important component of Langchain, and I implore you to check it out more in our document, in our material. And with this, I think we have come to the end of this section. In case we have any contribution, questions, feedback, I think we can do that now. Thank you.
All right. Thank you so much, Ridwan. Guys, please, if you have questions, ask your questions, or we end the class if there are no questions whatsoever. Okay, with that then, I think we've come to the end of the class. Thank you so much, Ridwan. See you all next week, Monday. Thank you so
Yeah.
much, everybody.
Yeah.
Yeah.